Professor Belden, this is Chapter 10, Section 1. This is Part 4. We're going to try some problems in context now. So we have two fire stations, or towers. Tower A is 50 degrees north by east, and the Tower B is north by 36 degrees west. Those are both bearings. So essentially, what a bearing is just a compass. So you draw a compass, you get north and south on a compass. A compass has east and west, but the part that spins is north and south because it's the magnetic part that spins. So if it's 50 degrees east, essentially you get 50 degrees to the easterly direction. You get a vector, essentially. Draw another south and north compass over here, but this one is 36 degrees west, so that's west, so 36 degrees. Right, so eventually these will meet up somewhere, and there's your fire over there, basically. And then these two towers, Tower A and Tower B, are directly east-west of each other by 20 miles. So that's essentially what we get for a triangle. I'll redraw this better in a second. So this is obviously 90, because the compass is always going to be 90 there. 36 plus 54 gives me 90. And then 50, so this would be 40 degrees right here. Okay, alright, so that's basically what we have. That's how you do bearing. You just draw compasses and go east or west from there. Okay, so essentially if we draw a nicer picture, we will get this, right? Okay, let's do a math type here. Alright, so if we think about this as an angle, side, angle, which means law of sines. The problem is I don't have any ratios. I have angle B but not side B, angle A but not side A, side C but not angle C, which I can get angle C though, right? Because if I do 180 minus the two angles that I do have, which are 40 and 54, I will get angle C. So let's put the little angle symbols in there. Copy, paste, paste. Make that all blue, color, blue, so that's going to be 94. From 180 will be 86, right? Okay, so that is angle C. Okay, so I actually do have a ratio now. Whoops. Right? Oh, I don't want that. That what does blue. Okay, so now we can actually do a proportion. And again, you can put the angle on top or the side on top. It's up to you. I like to put the angle on top myself. So angle C is 86. And that is 20 miles for that side. Okay, so we need to do this twice. We need to do this once for A and once for B. So A is across from sine of 40. And we'll copy this and we'll paste it over there. And side B is across from 54. Okay, so you do this twice and we'll get the two missing sides, which are the distances they are to the fire, basically. Okay. Alright, so if I cross multiply, this is going to be A times the sine of 86 equals 20 times the sine of 40 when we cross multiply. And the other one is going to be B times the sine of 86 equals 20 times the sine of 54. Okay, so we're going to divide. So A equals the ratio 20 sine 40 divided by the sine of 86. And B is going to be the ratio of 20 sine 54 over sine 86. Okay, so A is approximately, and B is approximately. This is where our calculator comes in. Okay, so ratio 20 times sine of 40. Again, if you don't have ratios, it's fine. Just do division and then just make sure you have proper parentheses, because the whole thing is divided by sine of 86. Make sure it is in degree mode. All right, so we get 12 point something there, and we'll copy this because it's pretty similar. So just need to change this to a 54. Okay, so 12.88, I guess, and then 16.22. All right, so 12.88 dot miles, and B will be 16.22 miles. Okay, so, and the reality is, side A is the distance for B, actually, and then side B is actually the distance for A. So the reality is, tower B is closer. So they're going to fly helicopters to go put that fire out. B is going to be closer. Okay. All right. So that uses bearing, which we'll be using throughout the remainder of the chapter. Pretty usage. You want to draw your north-south, basically. Okay, let's do a one that has a mix of right triangles and non-right triangles. So let's say we have a boat, and the boat does a reading, and it's 24 degrees to the lighthouse, right? So this is the lighthouse that's on the reef. Okay, you're going to go 4.6 miles, nautical miles, and do another reading. You're going to get a 58-degree reading to the lighthouse. So the problem is the reef goes out 3 miles, right? So if you hit it, you die. So we need a distance that's more than 3 miles. The question is, are we more than 3 miles out? If we're not, we're dead. Okay, so we need to test this. Okay, so we need to get this length here, but we need this length and this angle, which we can get because this is 180, right? So if I subtract from 180, let me think here, that'd be what, 122? 122, right? 122 and 58. 158 is 180 because that's a straight line, and then 24 plus 122 is 146. That would leave a 34 here. So this, because this is a non-right triangle, I have an angle and a side now that'll give me a ratio for this non-right triangle. So this is 34 degrees and 4.6 miles. Okay, so let's shrink this down a little bit, and we'll do our little math type over here. So our ratio, oh, let's do the angles first. We had 180 degrees minus the 58. Let's do those angles here. That's 122, right? Which gives us this angle right here. Okay, so format, color, blue. And then 180 minus 24 minus 122 is going to be 34, which gives us this angle right here, the non-right triangle. Okay, so now we can do our ratio. So we have the sine of 34 degrees to 4.6 nautical miles. In the US system, it's lowercase nmi. International, it's uppercase nm. Okay, so we're going to compare that because we want this side length right here, which goes with 24. So I'm going to take this, copy, paste, and we'll say sine of 24, and we'll call this the hypotenuse, right? So we'll call this as the hypotenuse right here of this right triangle, basically, right? And then I can solve for this distance right here in the right triangle afterwards using SOHCAHTOA. Because right now we're doing this triangle, which is a non-right triangle. So therefore you use law of sines, law of cosines. And basically, what do I actually have if I think about it? Well, this is an angle, side, angle, because we have this angle right here, right? So therefore, angle, side, angle. It is law of sines, right? Two angles. Okay, so we're going to cross multiply here. So we have h times the sine of 34 equals 4.6 times the sine of 24. So then we'll divide. So we get h equals the ratio of this divided by the sine of 34. We divide. Okay. So that'll be approximately something. Let's see what we get here. So ratio 4.6 times the sine of 24 in degree mode over the sine of 34. So I get 3.345 8, I guess. I don't know. That's pretty good, I guess. We'll do one more. 8.7. Why not? And that's 3 dots. Ellipses, nautical miles. All right. So that's h, though, which is this distance right here, right? So if I think about what I actually have here, it's going to work. Okay. I don't know why that didn't work. So I have h. So now I have a right triangle, so I have to do opposite and hypotenuse, which is regular old sine in SOHCAHTOA. Right? It's not law of sines or law of cosines because it's a right triangle. Okay, so picture layout square. Move this up to there. Okay, so sine of 58 degrees, so 58 degrees, this is the right triangle, equals the ratio of opposite over hypotenuse. So that's d over this many nautical miles, right? And if I go that many decimals, it'll be accurate enough. Okay, you definitely don't want to round that to 3 or something ridiculous like that. We should go several decimal places, right? So basically, d equals this number, because I'm going to multiply that number on both sides, times this, right? All right, so that's going to be approximate. All right, so what should we get here? So that number, 3.34587 times the sine of 58. So I get about 2.837 ... That's good enough. Nautical miles. All right, so what does that mean? That means I'm less than 3 miles from the reef. So you are dead. Because your boat's going to sink, you're in the ocean. Maybe they'll rescue you, who knows? I don't know. But you definitely did not make the 3-mile mark out. You're going to crash. Change course. That's the boat we're going for here. Okay? So, problems could be a mixture of right triangles, not right triangles, which was the point there. Alright, so oblique triangles, you can also find their area. 2 different ways. One way is if you know 2 of the sides and 1 of the angles. Okay? So let's say you look at the typical 1/2 the base times the height for a triangle, right? Well, that doesn't quite work if it's a oblique triangle. So it changed a little bit. So the base of this triangle, right? Again, we're using the same triangle as the first page of these notes. I'm going to draw an altitude, and the base will be C. This will work for A, B, or C, depending on how you turn the triangle around. You just change the altitudes. You just draw the altitude this way or draw the altitude this way, whichever way you want to do it, right? So again, you can draw the altitude this way or you can draw the altitude this way. That's however you orient it. The proof still works. Okay, so the base is C, right? Okay, so if I do the sine of A, that's the hypotenuse. I'm sorry, the opposite over the hypotenuse. This triangle right here, this little triangle, that's triangle 1, that's triangle 2, right? That is the opposite, that is the hypotenuse, so h over b. Okay, so I want to get rid of this ratio here and do h over b. Okay, so if I multiply both sides by b, that'll get h by itself, right? Multiply both sides by b. So I will get b times the sine of A. Right? Multiply each side by b on both sides, you'll get this. So this is my new base. And this is my new height for an oblique triangle. So if you don't have a right triangle, it's fine. You can still do the half the base times the height. You just have to modify it a little bit based on what you have here. So what you'll notice is there's three versions. Okay, if you have side A and B, you'll need angle C. If you have side A and C, you'll need angle B. If you have sides A and B, you'll need angle C. So you'll notice it's A, B, C, A, B, C, A, B, C. Right, so whatever side you have, you need the other angle, basically, is the way it works. Okay, so if I look here, I have sides A and C, B and C, but I don't have side A, which means I need angle A to be able to do this, right? Because it's B, C is the sides, therefore I need A is the angle, right? So therefore I need this version right here, right? Because I'm missing the A angle. But I can get the A angle though. So let's make this blue. Format, color, blue, and move it down. Okay, so I do have a couple angles here. Let's scroll down. I have, so I have 180 minus 93 minus the 25 are the two angles I have. So copy, paste, paste. So let's see, that would be 62 degrees would be the missing angle. So that is angle A. Okay. Copy, paste. Okay, so we know side B, that is 10 meters, and side C is 24 meters, and angle A is 62 degrees. Okay, so the area equals, we'll go to our calculator now. So 0.5 times 10 times 24 times the sine of 62. So we got 105.95, that's close enough. 105.95 dot dot dot, and that's going to be approximate. And that is going to be meters to the second power, because meters times meters is meters squared, which also is an area. Okay. So the biggest thing with this is making sure that you have the correct angle in the sine. So here we had to have found the 62 because it's the included angle basically between the two sides that I have. We had C and B, which were not helpful, right? Because it has to be a combination of A, B, and C for each one of these essentially. That's the end.